Welcome, colleagues. Thanks for your time and attention. This is a pre-record of our normal 30-minute bi-weekly teleconferences we have with roughly 100 electrical professionals across the education and healthcare facilities industry. We promised a 30-minute teleconference. My hope is that in the future we'll be able to get these down to 20 minutes. We understand that everyone is short on time, especially in the public sector. We're spread rather thin, so when we get to produce these a little bit better, we think we can get them down to 20 minutes. So for the moment, you're looking at our typical unvarnished, ad hoc, unrehearsed teleconference on electrical systems for educational healthcare facility electrotechnology. Keep in mind that this teleconference is recorded and will be available to the attendees on this call only for a few hours. That would be my colleague Ryan here, but it will eventually be publicly available. So I'll start by just restating I'm Mike Anthony, Senior Manager of National Infrastructure Strategy, and we have Sir Ryan Giorio on the call also. Ryan?
Ryan Giorio, Oakland University, Senior Engineer.
And so what we'll do is to rip through this. As you know, we've given priority now between now and November 7th. We're dealing with two deadlines. The first one is the traditional paper deadline. That's important because some of what we're asking for is changes in the tables of the NEC. So we'll have to work on paper there. I think it's easier to work on paper for those of you who haven't been to the new NEC platform. We'll probably deal with that in a couple of weeks so you can see what that environment looks like. And then, of course, before then we'll have at least two other teleconferences before we get into the new electronic platform on November 7th. So we'll try to key in a few examples there. This meeting, again, is just to bring everyone up to date at the progress of our thinking over the past several months. And what you're going to see here, two documents I want to point out to you. One is these are the concepts that we have proposed for the 2017 revision cycle. I have them in order of section number. Also on the same also on this second link here, we're looking backward to what we did at the last cycle. We're refining some of this. You'll see here that you will not see everything here on the you won't see everything here that you'll see here, and then you're going to see some new material. Ryan had just mentioned something earlier today about how he has some other ideas about what we want to do with the article emergency power. There's some unclarity there. So we're going to let Ryan talk about that in a few minutes here, but let's get to our first items here. We're not going to go into justification. We're just going to rip through this, and I have some colleagues around the country that are interested in putting these out. I've talked to them over the past 2 years, so let's just march our way through them. Any thoughts here before I start marching through this, Ryan?
No, sounds good. Okay,
good. So you might recall that we did get Annex I put into, I think, is Annex I the, I always get them mixed up. I'm going back to the NEC right now. I believe it's, yeah, Annex I. This is something that I was able to do with Crystal Hunter and the people at UL and CSA. So we now have torques for both copper and aluminum. What happened, however, is that it was a correlation error at the Technical Correlation Committee. They actually approved this change, but when it came down to printing, they said, we don't like the way it looks on paper. So even though conceptually it got through on Annex I, up here farther upstream in 110.5, you'll notice that you're going to see me rip through this. I regret some people say that I moved too quickly, but here is the section where we would like to change, and so we'll get that fixed there. Let's see here. Now, along this line, okay, so one of the underlying philosophies of that has informed our proposals over the past several years is that we need to bring the fire safety rules in line with what we're seeing in energy conservation. And we're seeing energy conservation take the heat load down, and when you do that, it accrues to many other parts of our system. And this is a case here. This is actually out of order. This belongs down here. But you'll see that we're going to be trying to present these committees with some challenges. We're going to ask them to permit medium voltage size feeder sizing based on historical data. And when you look at this, we actually have an escape clause here in Article 220.87, which allows people or engineers to specify a renovation or an expansion to an existing facility. And this has often been used when you're adding, say, another wing to a building. You'll just take, if you're just doubling the space of an existing laboratory, then why not use the load that you've already seen? So the committees are very exacting about what they want to see here. So this has been a case where you use demand history for renovations. We'd like to expand that notion so that you use the demand histories of actual for new buildings. So thoughts on that, Ryan, while I catch my breath? No? Okay.
No.
All right. So we're going to get into some some interesting ideas here. However, we're going to be asking for the committees to revisit the 125% rule, which has been around since dinosaurs roamed the earth. And you will find that many of our colleagues in Europe, for example, are more specific. They don't have a one-size-fits-all rule for conductor sizing and overcurrent protection devices. So you'll begin to see us putting some ideas out there. And my colleague from the University of Rome is the guy University of Rome, Professor Parisi. He's the guy that'll be who will be helping us with that one. So, and he'll be aided by Crystal Hunter from General Cable. Okay, so here is where the IEEE 3000 series, I probably should have called that up. The IEEE will have a 3000 series. These are the documents that will be replacing the old color books, and so we'd like to see these ideas then tracking in the NEC. Instead of the color books, you'll notice that in several places in the NEC they refer to the color books, so they're being replaced with this. IEEE wanted to do that because they believe that design rules within buildings need to move faster, and they felt a smaller standard that was electronic in nature would be suitable to what engineers need now. Okay, so you'll see that idea through several of these articles. I believe we talked about new design. Okay, so we talked about giving engineers more design discretion. Right here. Oh, I see. This carries over. So this was from last cycle. And what we asked them to allow us to do was to allow schools and classroom buildings to be handled as if it were a unique occupancy class. If you go back into the NEC, you'll notice that a lot of industries have come through here and have asked for their own types of exceptions. So we're going to be doing that also. I think you see shop windows here, restaurants, farm loads, all the industries that were able to produce data that the committee felt comfortable with came by and got exceptions. So we'd like to see more of that also for us. What else do we have here? Okay, so this is what I'm hoping Ryan will go after. You ready for this one, Ryan?
Why not?
All right, so if we go back over here, I think I've even got you, I think that I've even got you on here as a perspective you understand, of course, the committee is going to say no the first time around, and my hope has always been that we're able to get, here we are. Remember that in the first part of the NEC, in the first part of the public input section, we only need enough of an idea to hold position on the agenda. This will be rejected because we won't have enough data. And my hope that sometime in the next year and a half, I can get the Research Foundation to do this. Now, by the way, those of you who don't know, I'll tell you what, we'll leave that for another meeting. We do have a website set up for the Research Foundation project that will give us the data that we need there. So I don't want to belabor that too much. This is an old canard with me. We have the ability to actually have incident energy readouts on the service metering. These three guys invented it. I felt that if we were to put this idea in the code that it's possible, and I think my suggestion was if you can get a direct readout of what incident energy is at the service, then you don't need to do all the calculations. So that is trying to make a market for impedance metering at new services. Okay, so this is another important idea. As you know, that the NEC only sees supervised industrial installations as being factories. We believe that campuses with large 24/7, 365 staffs ought to be considered a supervised installation. We have the better part of 100 electricians here at U of M. What do you have over there, Oakland?
We have 4.
You have 4. Are they? Well, at least one is on call all the time, right?
No.
No? Okay.
No.
Well,
they rotate who's on call between all the trades.
Okay. Well, I see. So your mechanicals and carpenters are all rotating. All right.
Yeah, but we're small. I mean, if we have an issue, people answer their cell phones and they come in. So
Okay.
I mean, everybody's on call in
Right.
a pseudo circumstance.
Okay, so we're going to go after this one again. I've tried to push this through in the past, and because I've got a number of important code changes lately, the committee might just do an ad hominem acceptance. That's my fantasy, at least. So okay, again, more medium voltage feeder sizing based on historical data would convey that low voltage idea into the medium voltage. Here we have expansion of high impedance grounded neutrals. This will do a lot for electrician safety. We basically cut incident energy at our substations in half, if not lower than that. It usually would be about 100 amps and lower, and compared to several tens of thousands of amperes going through a solidly grounded system. All that energy is redirected on a resistor that's placed on the bus. So this is a big deal as far as electrician safety goes. But more important is that in the high impedance, we actually have the instrumentation to tell us when there's a cable fault. And so in hospitals particularly, we believe that this is going to help for reliability. The ability to see a little light flash to say you've got a leaky cable, and then to do a scheduled outage as opposed to a forced outage. That's a big deal, especially in healthcare settings. So I'll be working with that one. Actually, these two are roughly the same, except this is the general rule, and this is the more specific rule. So there's probably not a better person in the world to deal with that than David Shipp. I'm happy to have him as a co-author with me. And Ryan, you probably know John Ogle, right?
Yes, I do.
Yeah, so he's got a lot of experience in factory settings where processes require continuity of power.
He laid out our medium voltage setup here.
Did he? You're solidly grounded though, right? I bet you he wanted to make
Yes,
it low resistance. Yeah, most everyone is, unless you can transition. You came to your system because it was already solidly grounded, right?
I'm sure. Yeah, it was before my time.
Right. So that's what the utilities want, because that's what the utilities want to give the customer what the NEC requires, and so the practice and design practice has been such that the utilities will actually prohibit a resistor on the neutral. But of course, in other settings, data centers and in mission critical systems, they have grounded neutrals. So we want to see that conveyed at least into hospital medium voltage systems. Okay, so more concepts having to do with can we use the forced error rating for demand swing? What are your thoughts on that, by the way, Ryan? This is a spot. So do you use the forced error ratings to pick up your demand? I know who your consultants are. They're probably not doing that.
For the transformers, you mean?
Right.
Do we do it? Yes. The rub is if you do it, the fans don't work. What do you do?
Yeah. Well, you have
So
an
always
overcurrent
the pitfall.
device. Yeah, you have an overcurrent.
More the political side of the building going down.
Yeah. Right.
That's that's more of the rub.
Yeah.
Right.
Right. Well, it just turns out we have to decide to what degree we engineer for something that happens, one out of 1,000, once every 10 years, just like the civil engineers, even the airline industry. To what degree do you make a system uneconomical for something that is so statistically unlikely? And that's what makes us engineers. We have to make that decision. And so there's a lot of ethics there, but there's also science. And frankly, a lot of this is just another day at the track. Okay, demand factors for HVAC. This one's tracking elsewhere in the past here. I'm mentioning this specifically because our colleague Mark Shapiro helped me with this. He was a great believer in this. He was a motor diversity factor guru. And so we felt comfortable that we could make some wild suggestions like this, that when you have the number of electric HVAC units in there, you could practically use a demand factor here. He felt that there would be a great deal of comfort. I don't actually have data for this. I think if you talk to our building automation system folks, they would do it, and they would say, well, why don't you just let us do it? But here we are building in supply and delivery capability that's never being used, which increases safety risk and obviously energy. So we're going to try to go after this one with some data this time, but I just wanted to make some mention that it was my pleasure to work with Mark in his last days on this one. Okay, in fact, I would say that just to be able to work on this is what helped Mark have a relative quality of life near the end, because he was very passionate about how the code could be used to help society. Okay, so what do we have here? The same idea, we're just carrying into a special place. We feel that we may be over-designing theaters to some degree, and we could probably do more with the building automation systems. This is a colleague from the Canadian side of the border, and this is a promise we had about fire pump conductor sizing clarification. It's something I said that I would not let the world forget. He feels very passionate about it. Basically, we're finding some unclarity, so to say, here in Article 695 about the sizes of conductors. So we think that we can probably get a little bit better about how we deal with fire pump conductor sizing. So I won't belabor that. It's a highly code geeky inspector type of an issue, but it's important. And just as you're struggling with Article 700, I think a lot of the fire pump design committee are struggling with that. So we'll get that fixed. Critical operations power systems. How are we doing on time here? I suppose I should have started a clock, but I feel that we're probably okay in terms of time. So we're 12 minutes in? Okay, I like the sound of that. So here we are with critical operations power systems. These are the guys. Angie was the head of the committee. He's from the Army Corps of Engineers. Bob Arno's our reliability guru. He lays down the numbers for most of the Department of Defense critical operations power systems. So we'll be noodling around with this a little bit. We believe that you can get more granular about the way Article 708 is set up right now, so we'll work on that. You will see all this stuff posted, of course, on this website here. All these ideas here, all those drafts will show up here before the deadline. What do we have here? All right, so this is what you were just talking about, Ryan.
Yep.
Jose and John are complaining about selective coordination. I will admit right here that I have not followed that debate. I felt that early on, now remember, of course, that I wrote the last book on overcurrent protection back in what was it, 1994 something, and I guess I'm talking my own book now here, literally I'm talking my own book. But wherever fine reprints are sold, folks, you can go to it. Where's that darn thing?
Drumming up the sales.
Drumming up the sales here. I don't know, where's that book? Somewhere around here. All right, so you just type in my name and look, overcurrent protection. All right, I'm not going to bore people with all this stuff. Suffice to say, here is the ISBN number right here. Where's my, yep, that's the ISBN number if anybody wants to get it. We didn't contemplate some of the things then that we have now, and so I'll just leave. We probably can do a little work here. We can probably do a little work about making the language clearer, but probably not the concepts. Okay, I felt Chapter 9, as you know, you have a number of calculations. It helps. Did they redo that? Where's the sample calculations? Here we go. It's Annex D. I'm sorry. So here we have a number of examples that are used, most commonly used applications. You know, sizing the neutral on services. So we felt that it's about time. There has not been a new example put in the NEC that I know of since I've been on the NEC, and I think that's something like I'm on to my fifth cycle now, almost sixth. So let's get some new examples in there that are relevant to what engineers are seeing in a world where we see more distributed generation and lower power densities. So we'll get that fixed. I'd like to see more correlations between our world and the European world. I'll work a little bit with, do I have that here? I guess I don't have that here. I'll be working with the IEC on that one. And Annex H, I think Dan we're getting close to the end here. Dan, I believe, is getting permission to make that change. He needed some internal permission to make a statement, and so we'll respect his organization's need to confirm that. Let's see what he's got. So what we're asking for is this. We're asking to make sure that the electrical boards have representation of the fiduciary of final resort. As I like to say, that it's burned into the NEC and the IBC documents that the usual suspects should be there, but with all their good intentions for safety and such. But the guy who's got to pay for all those good intentions is right here. And it's not like that guy doesn't want safety, but remember, that guy's got to deal with 50 other claims for safety. So how do we reconcile it? Well, the first step is just to have him at the table. It may be irreconcilable, but let's get that guy at the table. So we feel that by getting this in the NEC, that we can make some progress in making that particular absence more politically visible and getting it fixed. So I think what I'll do here, Ryan, since I'm tired of talking, they're probably tired of listening to me, is you might want to say something about this. So you want to take the floor briefly before we're getting close to the end, actually.
What is this one about? This is
what you called in complaining about instantly.
Oh yeah, this is about Article 700.5. Yeah, the issue is we have a developer on site, and essentially he wants to put one ATS in, and he's saying that the code allows it. And speaking to engineering firms in town, they're essentially saying that the inspectors do not allow that, and they require a separate ATS for life safety systems, and then any other equipment on it needs a separate ATS. And so reading through the code, it does suggest that you need a separate ATS by just putting in specific words saying emergency systems in lieu of saying, well, you need a separate ATS for life safety and providing a detailed drawing like in Article 517. So I guess that's my complaint. If it was clearer and not so ambiguous, I think their debates with the contractors would be less, and we wouldn't have all this contention, I guess.
Is the project specifically a healthcare facility?
No, it's a sports dome.
Okay.
So everything's about money. So everybody wants to drive price down to increase profit margins, and it's private-public partnership. They're trying to drive those solutions, and you get the developer who obviously wants the lowest cost possible.
Well, at the university, we had obviously the emergency system, and then was the optional standby. We call it emergency and standby system. I'm happy to show them what we did, and we were fairly clear about it. It's just that for example, this is an extreme case, but it's not unthinkable to say, all right, so we've got to keep the lights going to get people out of the building. And of course, if you're in a stadium or open air stadium, just why can't you move them right into the field, for example, or somewhere down the voluntorium? But then there's another idea that, well, we've got hot dogs and other food that's going to be spoiled, and that also would be considered a life safety, not a fire safety issue, but you don't want your food spoiling and other things that could do bad things to people when power goes out. So at Michigan Stadium, we have an emergency system and a standby system, and there is a fair amount of crossover in the way, as I try to say here. And it turns out, to the audience here, this was a chapter out of my book. Again, wherever, I think this one still is in print. So this one is actually right there. And I was happy to work. Happy to work. A couple guys. Lucas is out of California and Milton's out of Florida, and we put this book together. And we foresaw a lot of difficulty with how the life safety concept tracks in different codes. In fact, what you actually can see here, if I'm not mistaken, if you go to our website, I think you'll see that problem. You'll actually see that problem in the article we wrote for SCUP, and I worked around it by using the notion of a backup power system, because it's that difficult. So if we go over here and you get down to here, this is my easiest way. So campuses as cities of the future. This is published in the SCUP journal last year. What we're looking at here is that I call it the Babylonian confusion that surrounds a backup power system. You won't find backup. We're using backup to describe both the mission of power system engineered for life safety and power systems engineered for protection of standby, protection of property, which is standby power. Property could be food, for example, or a radio system. So you'll see this in the IEEE, but you won't see this in the fire safety world. So we have some considerable amount of work to do on that, and admit it, and we'll try to get that done here.
Well, I think from my end, I mean, if the two folks I'm talking to at two large A&E firms in the city of Detroit essentially have been burned by the interpretation of the code, that you essentially have to put a separate ATS in for life safety. That's what they said.
Yeah, but those consultants are probably rolling between different jurisdictions in the country.
Those two are primarily, they do a lot of work in Detroit, and they know I was referring to that. So I mean, the inspectors are hanging their hat on that 700.5.
Okay, so another transfer switch is going to run them another what, $5,000-$10,000? Well, actually, when you wire it all up, it could be up to 25 grand. So I do get their concern. Yeah. Okay. Yeah. Well, it sounds like there's two parts to this. Do they have a specific design problem with interpretation of the existing code? My thesis is that we could get a little bit more granular by correlating. And what I want to say, I'm going to add to this while we're here. So we want to look at the International Building Code. We want to look at NFPA 110. And we want to look at, obviously, the NEC. We want to get these concepts moving together. These three guys here, each of them have a different notion and are using a different language for what life safety and standby power will be. Actually, I didn't put IEEE on here. Right here, these three. we need to do better on that. And even if we have to get a special work group set up for that, I think I can do that on the NEC. And I hope we will see you when are we meeting, Ryan? Is it December or January?
I think
At Hilton?
it's January.
Is it January?
January.
Yeah. Okay.
Yeah.
Yeah. Just
yeah,
so
I need to
everyone
get that ball moving.
Yeah. So Ryan will be accompanying me to the 2017 NEC meeting. So I think that's about all we've got time for, folks. I want you to see where we're at. You can see some of the ideas from the last revision cycle. We already have, I didn't number them, but we have the better part of 20 here, and each of these will have different variations. So I can easily see 60 coming out of these when you start making some larger code proposals. Sometimes you want to change words a little bit, so you'll submit them as different kinds of proposals with different kinds of substantiation. So I'm seeing here, just on this list alone, the better part of 100 new individual proposals, even though the number of concepts are probably only about 20 or 30. So that's it. Anything else, Ryan?
Nope.
No? Okay, then.
That's it for me.
No closing reflections. So then the next time we meet online will be, when do we meet next time online? 2 weeks from now. And will that be when ANSY's 23rd? That would be October 7th. You know what? I think I am I might be in flight from Vancouver. I'll be at the IAS meeting. Some of you probably know this already, but we will be having is what we're calling an education and healthcare facilities group set aside. IEEE is going to form a electrotechnology committee, and that's one of the reasons why I guess I'm not going to be here. I'll be at the IAS conference. If anyone's else going to be there, I know this clip will be going, well, basically they're all 50 states, because I believe we have about 100 recipients of our biweekly emails. So if anyone's going to be there, let me know. I'd be happy to meet with you in person. So then until, I probably have to pre-record this one also, Ryan.
Okay.
So let's think about that. But it will be up there no later than, this one, frankly, will probably get up there tonight. So look these over. You're always welcome to call me, or you're welcome to call Ryan or email us. I think our contact information is here. And thank you very much for your time and your expertise. I hope this was helpful. Okay, Ryan.
All right.
Thanks very much. Take care.
All right, Mike. Have a good day.
You too. Bye-bye.